In this part of the review videos, I'm going to just go over simplifying some radical expressions. All right, the next part, I'll get into solving these radical equations and then graphing them. All right, so this first one says the cube root of 108 x to the 7th power y to the 10th power. I personally like to split this up into 3 separate cube roots because the way that I do this with numbers as opposed to variables is different. So if you're having trouble breaking this down, you can break this up into different factors that you know of 108, or if you don't, you can divide it by 2. But for this one, I know I'll use 27 times 4, right? 20 times 4 is 80, 7 times 4 is 28, adding 80 and 28, you get 108. If you don't know that, just keep breaking it down, all right? And then this one, the way I do it is I ask myself, how many times does 3 go into 7? And it goes into twice, so I'll have x squared on the outside. And 2 times 3 is 6, so there would be 1 left over inside. Same thing here with the y. How many times does 3 go in to 10? It goes in 3 times, so y cubed. With how many left over? 3 times 3 is 9. So there's 1 left over on the inside. Now, this cube root of 27, I do know. That is 3. So I take all the things on the outside, 3, the x squared, the y cubed, put them on the outside, and then the stuff that's left over stays inside that cube root. Okay? This can be tricky, so make sure you're reviewing this. Let's go to B. Now in this one, I take the stuff that is inside these cube roots and I multiply them together. Again, that's not the only way to do this, so I write 24 and then x to the 7th power. Remember, when you multiply with the same base, you're actually going to add those exponents. Okay, so doing that same process of splitting this up into the numbers and the variables, okay? In terms of factors of 24, I'm going to do 8 and 3 because I know the cube root of 8. And this one, if I ask myself how many times does 3 go into 7, it goes in twice with 1 left over. Okay, so again, I do know the cube root of 8 is 2. That 2 times the 2 that's already out there gives me 4. X squared, that's outside. And what's left inside is going to be the cube root of 3x. Okay. Again, I put this little dot here so I don't get my exponents and indices confused, but you don't have to put it there. All right, letter C. Now, letter C, unfortunately, if I were to try to break down this 4th root of 20 into a number of 2's, I could do 2 times 2 times 5, right? That would be 20. But because the index is 4, you need 4 of one number to be multiplied together to be able to pull out one of those outside the radical. Same thing if I did 45. That'd be the 4th root of 3 times 3 times 5. I don't have 4 of a number. And same thing with 125. I don't have enough to take out, right? I'm going to do 125 over here. That's 5 times 5 times 5. There's 3 of them, but not 4. So actually, I can't break this down at all. And so because they don't have the same radicand, which is the number underneath the radical or inside the radical, you cannot put these together. You can't do anything with the stuff outside. All right, so this is actually fully simplified. Okay, let's do D. All right, now if I do these separately and then I'll put the stuff back together, I know the cube root of -8. The cube root of -8 is a -2. The cube root of a to the 6th power, 3 goes into 6 twice, so that's a squared. And then in terms of my C, 3 goes into 7 twice, and then there'd be 1 left over. Okay, times. I cannot do anything with the cube root of 7. 7 is a prime number. And in terms of my A, I don't have enough inside, right? 3 can't go into 2 evenly. There's not enough inside, so that's going to stay a squared. But in terms of my C, for this one, 3 goes into 14 4 times, so that's C to the 4th power, and then there's 2 C's left over. So putting all this stuff together on the outside, I get a squared, that's C to the 6th power, right? Remember, you add those exponents. and then putting this stuff together, I get 7a squared, and then watch this. This is c to the first, so that becomes c cubed, and now I do have enough, right? Remember, this matches, so that's going to give me another c on the outside to give me c to the 7th power, which means I don't have any c's left over inside the cube root. Okay, if you wanted to put the, oh, I forgot my square, sorry about that. If you wanted to put the c to the 7th in front of a squared, that's fine. It's your call. Okay, let's go to the next one. Letter E. All right, this one is, I cannot leave a radical in the denominator, so I'm going to multiply by the conjugate of this denominator, which is 9 plus the square root of 2. Remember, the whole point of doing this is so that when I multiply my denominators now, I will get rid of any radicals. Now, 1 times each of those on the top is going to stay the same. But when I distribute, I get 9 times 9 is 81, plus 9 root 2 minus 9 root 2. You should not be surprised that these are going to make 0, right? That's the whole point. And then I get minus the square root of 2 times the square root of 2, which is the square root of 4, which is really just 2. So I get 9 plus root 2 over 81 minus the square root of 4. Well, I know the square root of 4 is 2, so that would become 79. Don't forget to check if this 9 and the number in front of the radical and the denominator can all be reduced by the same number. You should divide them out by that number. Okay, now in this case I can, so I'm done. Let's do F. All right, I'm going to deal with this one on the left first. So breaking this down into the 4th root of, let's see, I believe 16 can help me here, because 16 is, I do know the 4th root of 16, that is 2, all right, times the 4th root of, that would be 16 times 2 is 32, times the 4th root of a to the 5th power. So that's going to be 5a times 2, which is 10a. And then in terms of what else is left on the outside, let me write this 4th root of 2. And this would be 4 goes into 5 one time, so a to the 1st power, times the 4th root of a. So putting that all together, I get 10a squared times the 4th root of 2a. So that is my left side, this one here, simplified. Let's do the right side of this subtraction. All right, so the 4th root of 2, and then times the 4th root of a to the 9th power. Well, I can't do anything with the 4th root of 2, so I'll leave that. But 4 goes into 9 twice, so a squared. And there would be 1 left over. 4 times 2 is 8, so 1 left over. So putting this together, I get minus a squared times the 4th root of 2a. And this is important because if you look inside the 4th root, they have the same radicand, so you can actually subtract the stuff in front. So 10a squared minus 1a squared is 9a squared times the 4th root of 2a. So that is the answer to letter F. Okay, let's do G. All right, G, the way you can do this is you can split them up into separate radicals if you want, but I actually recognize that negative 128 can be divided by 4, right? 4 goes into 12 3 times, and 4 goes into 8 twice, and it's just a negative divided by a positive is a negative. And I know the 5th root of 32 is 2, so the 5th root of negative 32 is negative 2. And if you're having trouble with this, and you're like, whoa, there's a negative inside there, that's fine. Whenever the index is odd, you can have negatives inside radicals. Okay? Okay, H. Let's split these up again. 4th root of 48 times the 4th root of x to the 7th power times the 4th root of y to the 13th power. Let's break down 48. So that's going to be, I heard people say 8 times 6 today in class. This one I can ask myself, how many times does 4 go into 7, which is 1 time? How many left over? That would be 3, so x cubed inside. How many times does 4 go into 13? It goes in 3 times. So that'd be 4 times 3 is 12, so that'd be 1 left over. I'm going to keep breaking down this one here to be the 4th root of 2 times 2 times 2. Hopefully you're okay with that. And this is 3 times 2. And if I put them all together to be 2 times 2 times 2 times 2 times 3, which is 48, you should notice that this index is 4. I have 4 2's being multiplied together, so that means there would be 1 2 on the outside. All right, and if I bring down my other pieces, so these 2 pieces and these pieces, I can write down my answer, which is going to be 2xy cubed times the 4th root of 3x cubed y. All right, 2 more and then I'm done. Another one where I want to multiply by the conjugate of this denominator, which is going to be root 2 minus root 5. Remember, you just copy it, but change the sign in the middle to be the opposite. All right, again, the whole point of doing this is that this original denominator times its conjugate will get rid of any radicals. So multiplying the numerator, I get 2 times root 2, and then I get 2 times negative root 5, which is minus 2 root 5. Root 10 times root 2 is root 20, and then minus root 10 times root 5 is minus root 50. Okay, let's do the denominator. Root 2 times root 2 is 2. I'm going to write minus, and that's going to be root 10 plus root 10. You'll notice those go away to 0. Minus root 5 times root 5, which is going to be just 5. All right, let's simplify the top as well. So that's 2 root 5. Root 20 I can break down. I'll do a little work over here. Root 20 is the same as root 4 times root 5. So that's going to be 2 root 5. And then I'll do root 50 breaks down to root 25 times root 2, which is going to be 5 root 2. Try that again. There we go. And then all over my denominator, remember these make 0. So 2 minus 5 is negative 3. Let's combine like terms in the top. I've got 2 root 2 minus 5 root 2, which is negative 3 root 2. And then, oh man, look at this. These minus 2 root 5 plus 2 root 5 make 0. My negative 3's are going to cross out, so I get just root 2 in the end. All right, last one, letter J. I'm just going to FOIL here. Root 6 times root 3 is root 18. Root 6 times 2 is 2 root 6. Negative 4 root 3 times root 3 is minus 4 root 9. And then minus 4 root 3 times 2 is minus 8 root 3. So root 18, I'm going to break that down into 9 times 2, which is 3 root 2, plus 2 root 6 minus 4 times 3, right? Root 9 is just 3, minus 8 root 3. So 3 root 2 plus 2 root 6 minus 12 minus 8 root 3. I don't think I have any terms that have the same radicand, so I'm just going to leave all of this, and that is fully simplified. None of them have the same number inside the radical, so I am done simplifying. All right, guys, that is it on simplifying radical expressions. If you haven't taken the Quizlet on this, it's coming. If you have, hopefully it went well. Check back in for the next part of these videos where I solve some radical equations and graph some radical functions. All right, see you soon.